Hello, my name is Tae Kim, and I'm a PhD student at Professor Chung's IIDS lab. I'm gonna introduce some basic information about our lab and some of the research problems that we're trying to solve. Our lab is quite young and it's been only 4 years after our lab has started. We currently have 6 PhD students and 3 MS students. Our lab is located on the second floor of N1 building, and our homepage address is iids.kaist.ac.kr. We have a meeting with professor about an hour per week, and we usually have a meeting individually, but you can have a group meeting if you have similar research topics with others. And there is no mandatory rule for working time, so you can use your time in a way whatever you want. If I have to choose one keyword that best explains the research in our lab, I would choose data science. And I think there are 3 common components in data science problems. First, there is information or knowledge that we want to obtain. Second, we are provided with some observation about the information, but this is sometimes incomplete or it can possibly have some noise in it. Lastly, we have to come up with a good algorithm that can recover the information from the observation. Some commonly asked questions in data science are how to observe information, how to select value over data within a noisy data set, how many observations do we need to recover the information, what is the best recovery algorithm for the observations, and within what error rate can the algorithm recover the information. The first data science problem I will introduce is crowdsourcing. When we make a dataset, we have to assign labels to each data, but if we exploit experts to label the data, it is very expensive. The idea of crowdsourcing is to collect data from some easy-to-assess, unreliable non-expert people. You might have seen a simple question like whether an image is cat or dog when using internet. And it is actually an example of crowdsourcing. We ask about an image several times to random people, and then we infer the true label from the image. The most difficult part of the crowdsourcing is that some people give very reliable answer, but the others give just random answer. So we have to distinguish the reliable people from the data and use the answers from those reliable people only. The next problem is matrix completion. The goal of the matrix completion problem is to recover every entries of a low-rank matrix given only some of its entries. The most famous example is the Netflix problem. Suppose we make a table with users in each row and movies in each column. Each entry of the table is the rating that a user gives to a movie. Because a user cannot watch every movie, the table will have many empty entries. But if we can recover the full table only from the available entries, we can provide users the expected rating about the movies that they have not seen. So matrix completion is one of the most basic algorithms for recommendation system. The third topic we study is robust deep learning system. Usually the dataset used in a deep learning system is not clean and contains a lot of noise data. So we have to come up with a robust learning algorithm that performs well even if the dataset is noisy. Also, in many cases, datasets are not uniform and there exists some class of data that do not appear well in the dataset compared to the others. In this case, a deep learning system cannot learn about this feature well because it may be considered as a noise. So we apply data valuation algorithm first to distinguish the data points that do not appear well and change the learning algorithm according to the value of each data. The last problem I will introduce is graph matching. Social network companies like Facebook knows who is connected to others. We can describe this relationship between people with a graph where each node indicates users and an edge is created between two nodes if they are friends in Facebook. Then a large graph is created, and also under similar users, other social networks like Twitter create another large graph. To make big data, we may gather data from different social network services. However, companies usually anonymize our users due to personal privacy problem. So we do not know which node in one graph belongs to a node in the other graph. Therefore, the goal of graph matching is to match the nodes in many different graphs, using graph structures only but not using any personal information. This is the end of my presentation, and if you are interested in our lab, please contact either through my email or the professor's email. Thank you.